just close everything first. There you go. Okay. All right. So before we move on to the next module, which is the week 9 and 10, or the module for other types of sensors. So does anyone has a question or clarification or concern regarding from week 1 up to week 8, or even with our midterm exam? Anyone? If none, just give me a quick thumbs up just to let me know that you don't have a question or any concern. Okay. All right, so that's good to know. 80% or 90% of you doesn't have any problem. Anyway, before we move on to the week 9 and 10, okay, I made some adjustments with your due dates in here. So supposedly this will be due. So what happened to my little calendar? So this will be due today, March 4, but I adjusted the due dates until March 11, because I've noticed that only half of you were able to finish, up to lab 14 or even 13 or even 12. So what I did is I adjust this one into March 11. Okay. Anyway, we now only have a few laboratories left, for the module 4 and module 5. Well, in fact, there is only one laboratory for this week 9 and 10. Okay. Anyway, so yeah, to those who are in rush, so you guys still have 1 week, or to those who are not yet done with the 10th to 14th lab, so you guys still have 1 week from now to finish those laboratories. Okay. All right. So let's now move on to the week 9 and 10, which is the module 4. So since we wasn't able to have a discussion regarding with this module, we're going to have a short lecture discussion for today's meeting. So we might be able to finish this one in maybe 40 to 1 hour. So that depends on our pacing. But yeah, we'll try to finish this one as as fast as we can. So for the module overview, so everything is the same. So you'll see the topic learning outcomes. So we only have 2 topic learning outcomes. So I will explain the concept of sensors and their classifications, and then explain the different types of sensors. So just those 2. And then here are the list of topics. So mostly the different types of sensors, what is real-time application of sensors, what are the classification, and then the different types of sensors that, the most common types of sensors that we are using when it comes to industry. Okay, so we have a bunch of more sensors out there that is not listed in here. It's just that these are just the common. So there are more, maybe hundreds, okay, or maybe even thousands of another kind of sensors. Okay, so we only have one module for this one, and then I did include 3 external links that came from YouTube. So just check this one out later on, and then one PDF, which also talks about the different types and then characteristics of sensors. Okay, so are we clear with the overview? Anyone has a question?
Wala naman po, sir.
Good. So let's now move on to the module itself. So before that, I'll just show you that there is no pre-made video, just the external videos that came from YouTube. And we have 3 practice exercises and then 1 laboratory. So we'll go over with this one later on once we're done discussing the module part. And then 1 case study also. Okay. All right, so let's now proceed to the module 4. So are you guys
Sir,
ready now? Yes?
sir, wala pa nagpapakita yung desktop niyo lang po.
Just my desktop.
Yes, sir.
So ito, yung nasa screen ko, wala kayong nakikita?
Wala po, sir. Yung desktop niyo lang po.
Kailangan kaya mag-restart. Green 1. At nagkabaliktad.
Okay na sir, meron na po.
So anyway, so I'll just show to you guys this one, the module overview. So the concepts and classifications, and then the list of topics. Again, we have your different types, classifications, and then what is real time, and then the different kinds of sensors, or the most common types of sensors. Okay, and then again, one module, three external links, and then one PDF. Okay, and again, for the watch videos, there is no pre-made video. So what we're going to do right now is we're going to discuss the module 4, since there is no pre-made video for this one. Okay, and then three practice exercises which talks about, or about, which is about sensors. So if you want to take those quizzes, so feel free to do so. And one laboratory which we are going to discuss later on. So I will skip this one for now, and then also the quiz study. Okay, so yeah, just those. Again, I did move the due date of your 10th to 14th lab, even the case study, until March 11. Okay, so again, to those who are not yet done with those laboratories, you still have 1 week from now. Anyway, those are just the things that I wanted to mention before starting the discussion on the module 4. So are you guys ready now?
Yes, sir.
Yes sir.
Great. So let's start by differentiating the types of sensors. So first, we live in the world of sensors. So you guys already know that one, we are actually living in the world of technologies right now. So you can find different types of sensors everywhere. Literally everywhere. So in our homes, offices, cars, even in the roads, we already have this uh, light wherein if it senses someone is walking or a passing by, especially if it's night, then it will automatically turn on its light. So anywhere we go, there's already a sensor. Okay. So we're going to make our lives easier by turning on the lights, by detecting our presence, adjusting room temperature, detect smoke or fire, make us delicious coffee, open garage doors as soon as our car is near the door, and many other tasks to make our life easier just by having different kinds of sensor, and then just by implementing that one and then making that one automated into uh, a certain device. Okay, so all these and many other automation tasks are possible because of sensors. So before going to details of what is sensors, so what are the different types of sensors and application of these different types of sensors? So we will first take a look at a simple example of an automated system. Okay, on what is the most benefit or the most use of sensors, and why do we have sensors? Okay, so that is because of this technology. Where is it? One, automation. Okay, the word automation. Okay, so because of that technology, so we were encouraged more to have a lot of sensor. Well, in fact, if we can automate everything and then we can sense everything with the use of a certain technology, then of course we will do so. Okay, to make our lives easier. Okay, so which is possible because of sensors and many other components as well. So let's have this a real-time application of sensors. This one is really useful when it comes to automation, which is the term AutoPilot. Okay, AutoPilot system in aircrafts. So we already have autopilots also in cars, but only for Tesla. Well, some people here in the Philippines already have the car, but it's not that yet. Uh, you know, most commonly used, since of course it's expensive. But yeah, that is the future. Okay, that we already have right now. Or that is the technology that we have right now. Okay, so automatic flight control system. So basically, we have the sensors right here where you see the inputs, and then the inputs will be processed by the computer, and then of course it will provide a certain output. So could be to the engine, to the flaps, to the motors, or to the wings. Okay, so let's go further on what is this automatic flight control system. So of course, it can detect maybe the speed, speed control, the height, the position, the doors, obstacle, or even the fuel level, or the maneuvering, and many more. So I'm not that really expert when it comes to you know, how to drive or what are things are happening in an airplane. But here are the basics, that it can control, it can sense, or it can automate. Okay, so computer takes data from all the sensors and process them by computing them with pre-designed values. Okay, so I will not go further on speed control, height, etc., etc., just to give you guys an idea what is happening with this automatic flight control system. So in here, well, there's more explanation about how to automate things, engines, flaps, and ruders. So the combination of sensors, computers, and mechanics makes it possible to run the plane in autopilot mode, or the technology that is so-called automation. Okay, so sensor is the, well, let's just say that it's one of the major factor to make this automation work. Well, computer is um, already has a lot of sensors, but let's just see, it's just a computer for now. It's, setting aside on what's happening in that computer. The same with mechanics, with the hardware or the things that is happening on that mechanical part. So we will only focus on the sensors for this module. Okay, so yeah, those three main parts. Okay, of or let's see, three or let's see, we have three parts to make this so-called automation work. Okay, not just the sensors, not just the computers, and then not just the mechanics. Okay, so we have three parts for this technology. Anyway, but yeah, we'll not go over with this automation. It's just that it is the main benefit, or why we have this sensors. Okay, so let's just say that this is the uh, main fruit, or let's just say that this is the main, or yeah, the main product of these sensors right here. So all the parameters, sensors which give inputs to the computers, the brain, the system, some more explanations on what's happening, but I'll just skip this one since this one is very straightforward. So again, in this module, we will only concentrate on the sensors, okay, not on the computer, not on the mechanical, etc., etc. Okay. So first, let's define again what is a sensor. So a sensor is an input device. So I already mentioned this one a while ago. So which provides an output signal with respect to a specific physical quantity. Okay, mostly a sensor is always an input. Okay, so it could be a double sensor, which let's say it is coming from this sensor, which is already an input, wherein there is another sensor here which provides an output. So that is also possible. So double sensors from input to output, but mostly it is an input. Okay, like 90%, 95%, it is mostly used for inputs. Okay. And then we have here the different kinds of sensor. Okay, so we have color sensor, gas sensor, LDR, and so on and so forth. Okay, so we have LM35. So just check them out later on. So these are just the basic, when it comes to sensor. Okay. So there is another definition aside from from input and then creating an output. So it is also a device that converts signals from one energy domain to electrical domain, which is most commonly for uh, analog to digital. Okay, so that is one good example. By this definition, converts that energy signal or energy domain into an electrical domain. So for example, if you passes by to a smart light. So let's just say smart light, since it's using a let's see, smart technology, right? And it can sense someone's passing by, then it will automatically lit up its light. Okay, so yeah, a device that converts signal from one energy to electrical domain. Okay, so are we clear up to this point? Any questions or clarification so far?
Wala naman po, sir.
Wala naman po, sir.
Okay, so let's now proceed. So here's one simple example, or let's just see the simplest example of sensor is an LDR, or light dependent resistor. So it is a device whose resistance varies according to the intensity of light. Okay, so if the LDR is more, let's say we have more light that is coming or hitting that device. So a resistance or the resistance becomes very less. And then when the light is less, well, of course, it's the other way around. So the resistance of the LDR becomes very high. Okay. Wherein, of course, if let's just say that if light is less, then that is a time that it needs to turn on its light. Okay. So we call that one LDR or light dependent resistor. So let's just see that this one is useful. Let's say it's a standalone device which is using a battery. Okay. It is not connected to our outlet. Okay. So let's say there is a brownout. Okay. So it detected that there is no light that is hitting that LDR or light dependent resistor. So it will uh, give you a light, or it will lit up its let's say bulb, okay, or that whatever is that connected to the or LED or a bulb. Okay. So yeah, that is one example of the sensor. Okay. Well, there's a bunch of other examples that will make you understand what is a sensor is, but that is one of the most practical example. Okay. Well, I guess right now, even though I am not, I will not explain this kind of things. You guys already know, the benefit of the sensor is, but that is one practical example of the sensor, the LVR. Okay. So yeah, let's now proceed to the classification of sensors. So some classifications are, says by the different authors and experts. So some are very simple, and then some are very complex. Okay, but anyway, let's just divide them into active and passive for now. So active sensors is those are devices that requires an external excitation signal or power signal. Okay, while the passive sensors, of course, on the other hand, do not, of course, require an external power signal and directly generates output response. Okay, so one good example of this one is this, uh, through light. Light is emitting its light, and then it will be reflected through our, let's say, satellite, and then this one that it's detecting is the uh light that is coming from the sun. Okay, that is what is passive because it's dependent to the light of the sun. Okay, so it can see or it can detect how far maybe or what is that thing that is being reflected or what is that thing that is being sensed by our say satellite. So this one is a peak, so one is a tree, then how far is the tree, how big is the tree, and so on and so forth. So I don't know what's happening, but that's the way it senses things. So it's depending on the uh, emitted light or emitted sun rays that is coming from the sun. While on the other hand, the active remote sensing doesn't require the sun. So you'll see here that even though there is no sun, so it can provide its own lighting. Okay, it can provide its own reflective uh, lights wherein it can check what is this thing, how big is the thing, how large is the thing, how far is the thing, and so on and so forth. Okay, so this one is emitted by the sensor, not emitted, that is coming from the sun itself. Okay, so yeah, that's the differences when it comes to passive and active sensors. Okay, so we could say that I read in some articles that passive sensors uh, are not accurate, and then at the same time they are very cheap. Okay, while the active sensor is a little bit more accurate, but at the same time, of course, it's a lot more expensive because it's using other or more uh, sensors probably or more advanced of technology, okay, or more components in it. Okay, so this one is also using a radar imaging. Okay. Anyway, so those are the example of or that is one example rather of passive and then active sensing. Okay. So did you guys get the idea so far of what is an active sensor and a passive sensor?
Yes, sir.
Yes, sir.
Yes, sir.
Anyway, so let's move on to the more classification. So of course we have electrical sensors, biological sensors, chemical sensors, and then radioactive sensors. Those are just the classifications or categories that it can detect. Okay, so for electrical, I guess it's easy to understand. If there is an electricity, maybe then it detects that there is electricity. Okay, if there is no electricity, then it detects that there is no electricity. So I guess it's very straightforward. Okay, for biological and chemical and radioactive, so I don't know how do they sense those things, but of course it's a technology that it can detect maybe through biological things, chemical things, and then radioactive things. But most commonly, we will only stick with this electrical thing since we are in the world, in the world of computers, and then probably there is some part wherein you're going to apply biological, chemical, or radioactive, but most likely it's 90% electrical um, energy only, okay, or electrical thing only. Okay, so you also have this phenomenon thing wherein of course it could be via this wind, via this temperature, via this uh I don't know, but yeah, let's see, a phenomenon that is commonly or normally happening in our surroundings. So in here, the most or some of the common conversion phenomena are photoelectric, thermoelectric, electrochemical, electromagnetic, and then thermooptic. So those are the sensors that can be used through this phenomenon or common phenomenon. And then the final classification of the sensors are analog and digital sensors, which already done talking about in our past modules. Well, again, this review what is this analog. So analog produce an analog output. For example, a continuous output signal with respect to the quantity being measured. Or let's just say it's a physical thing. Okay, it's a mechanical thing. Analog sensors. Well, on the other hand, digital sensors is of course using a discrete or digital data, so it can only read ones and zeros. So it's only binary or any kinds of discrete data or digital data. Okay, so yeah, those are the classification of sensors. Again, we will only focus on electric ping sensor. Okay, so here are the different types of sensors. So most of this thing can measure physical properties like temperature, resistance, capacitance, conduction, and then heat transfer. So we have of course temperature. These are the commons. You guys probably already know these sensors. So we have temperature, proximity, accelerometer, IR, pressure, light, ultrasonic, smoke, gas, and alcohol, touch, color, humidity, tilt, and then flow, and level sensor. Okay, so those are the different types or the most common different types of sensors. So there are probably more. Okay, that is not included here, but these are already the common types of sensors. Okay. So we have here the temperature sensor. Well, I will not explain this one anymore since this one is very obvious. Temperature sensor senses the temperature. Period. That's it. Okay. And then more explanation regarding the temperature sensor wherein it could use an IC, which is an LM35, thermistor, thermocouples, RTV, and so on and so forth. So here's one project that you can check right now. So just visit this website right here on it on what is a temperature controlled system, and then it's the components that you will need, and then how to do that on the breadboard. Okay, and so on and so forth. Okay, so it's almost a complete project. 3D diagram, the components that you will use, and then explanation in each component. So what is this LM35? What is this? And so on and so forth. Okay, and many more. We even have here the like the black diagram of this project. Okay, and then its advantages and then applications. Anyway, just check this one out later on regarding with this temperature sensor. Okay. So any questions so far regarding with this temperature sensor?
None, sir.
Can you guys follow so far? Am I too fast?
Followable naman, sir.
Just let me know if I'm quite fast, since I'm doing that one, since I already know that you guys already know this thing. Okay. Well, here is the another circuit of a temperature sensor, which is using with the use of battery, thermistor, transistors, conductors, or even transformer, which being converted into transformer. My bad. This is not transformer, but this is a relay. Okay. So yeah, those are the components that's being used with this temperature sensor. So I think it's doable. This one is doable with the use of LV spice. Okay, and then we also have here a digital temperature controller circuit. Well, the only difference is maybe this one can display the some information regarding with the use of this for this one LCD display. Okay, so this circuit for controlling the fan automatically is on temperature. So I guess this one is very straightforward. If the temperature is quite high, then it will turn on the fan, maybe. Okay, so based from its title. Okay, and then if the temperature is low, wherein it's quite cold, then of course it will turn off, or the fan will not be turned on. Okay, so yeah, that's how this real temperature controller circuit works. And then we also have proximity sensors, wherein I guess you guys already know what is a proximity from the word proximity. This one is very common for our smartphones. So this is a non-contact type sensor that detects the presence of an object through radiation. Okay. So this one is most commonly used in application like smartphones or mobile phones, rather, cars, and then like industries, like for object alignment, and then ground proximity in aircrafts, and then many more. Okay, and then of course again check this website right here. Oops, cannot connect. Happen. Anyway, I don't know what happened, but just copy this link right here, and then just try to type that one on the website. Okay, let me know if this one will not work. So I will just check this one later. Anyway, yeah, that's how this proximity sensor works, through radiation. Okay, so we also have infrared sensor, wherein before this one is a through radiation that can detect objects. This one can also detect object. Okay, but it's now based from light. So this one is a light based sensor. Okay, so everything is the same. It's just that this one is using a light. Okay, so proximity uses radiation, so it doesn't need light, and light of course needs a light. So the one big advantage of proximity is, of course, this one doesn't need irradiation, I mean a light anymore. So in dark places, this one can still detect objects. Okay, so this one is useful for night uh you know night activities, that's happening without light. But in here, this one is most, of course, most useful through daylight. Okay, so yeah, that depends on your project, or your target. Okay, so both of them can detect object. Then here's one example that you can also check. I don't know what again happened. Good, but yeah, just check this one out. Also, if this one will work onto you guys. If no, just let me know so that I can maybe change the URL. So yeah, I don't know what happened. Anyway, let's move on now to the next one, which is the IR sensor. So if we have radiation, if we have light, this one is via, if not mistaken, this one is infrared. Where's that one? So this one used to emit and detect, yeah, to detect the infrared from the word IR. I guess this one is very straightforward. IR stands for infrared. Okay, so yeah, this one is also a detect, can also detect object, through the IR or infrared emitted, and then once it detects that obstacle or object, it will be reflected, then it will notify that there is an object in front of him. Okay, so yeah, those are the different kinds of object sensing. So with this, the use of radiation, the use of light, and then with the use of infrared. Okay, so again, that depends on your target. So they have their own advantages and disadvantages. So I'll not, you know, uh, go over to the details on the things that what is most likely to use if you have this project, what is the most likely to use if you have this project, okay, so on and so forth. Okay, so just if you want to use this specific sensor, just maybe try to research first on what is the best for that sensor, and then what are these disadvantages if you're going to use that sensor. Okay, so all of them can detect obstacle or object. Okay, so here is another IR sensor circuit that you can check. So this one is mostly used for remote control. Okay, since of course uh, this one is detecting well, I don't know, maybe the TV itself, the LED TV that we are seeing, okay, the red one uh, emits a infrared. Okay, so yeah, but this one is not limited to remote control for TV. This one can be also used for, as a remote for call this one RC car, remote controlled car. So let's just say that it is something like this. Okay, wherein of course it can emit, or it can also receive the infrared. Okay. Anyway, so this is an IR sensor controlled robotic vehicle. And then we also have ultrasonic sensors. So if we have radiation, we have light, we have infrared, we also have true sound. Okay, and that is ultrasonic sensor. So this one is similar with this one. You know, it provides, or it emits sound, and then it will hit this obstacle or object, and then it will travel back to this sensor or this ultrasonic sensor, and then yeah, it will notify that there is an object with this distance or with this range from that object. Okay, but this time it is via sound, by the time of flight of sound. Okay, so in here you can also check the velocity of the object. Okay, so I guess this is one big advantage of this sensor over the other sensors, because they can measure the velocity of that object. Okay, but in here we can measure that one, okay, with the use of ultrasonic sensor. So yeah, can you guys follow? Were you guys able to follow everything so far to this point?
Yes, sir.
Okay. So since we don't have enough time anymore, we'll just continue the rest on the part two. So goodbye for now, and then let's just meet again on part two.
Okay, sir. Thank you po.
Okay, so I guess we can continue now. So most of you are over here. So let me just check if everybody's over here. So just give me a quick thumbs up. All right. So 90, 95%, maybe. Anyway, so that's it for the ultrasonic sensor. So any question or clarification so far regarding with this one, or up to this point?
None, sir.
Okay, great. So more explanation on how does an ultrasonic sensor work. Anyway, so this is one example of a ultrasonic sensor circuit. So this is an ultrasonic module. So we have here the microcontroller, and then the ultrasonic sensor itself, and then we have also an LCD display to display some information. So yeah, just to give an example, or just to have an example with this ultrasonic sensor circuit. So I know that this one is not readable anymore, but yeah, just look more examples regarding with this ultrasonic sensors. You can find a lot. It's just that maybe this is what I I saw at that time, and then this is the one that I copied and then pasted on my module. Okay. Anyway, so yeah. So what else? Some more example, but yeah, similar again with this one. Okay. So it's just explaining here that whenever power supply is given to the circuit, the ultrasonic waves are generated and transmitted from the sensor and reflected back from an obstacle or an object ahead of it. Okay. Again, it's one receive, or the receiver receives. The total time taken for sending and receiving is used for calculating the distance between the object and the sensor. Thus, it can display now the probably the distance, in inches maybe, or in centimeters, or in millimeters through that object. Okay. So here's one practical application of ultrasonic sensor. So this one is most commonly used for inaccessible areas such as high temperature or pressure zones. Okay, so of course, people cannot just easily go into that place, high temperature, inaccessible area. So instead of letting people measure that one manually, so we can use ultrasonic sensor, just to send sounds, and then we can check already if there is an object or how far is that object uh, that we are checking. Okay. So next example of a sensor is a touch sensor. So I guess this one is pretty obvious already, but we have different kinds of touches, or touch sensor. It could be capacitance by capacitance touch, or it could be by a resistance touch, or it could be piezo touch switch. Okay, so here's an example of a touch sensor circuit. So we have the touch plate itself, and then we have the 555 timer, we have some resistors, capacitors, LED, and so on and so forth. So basically what this does is uh, once once the touch plate is touched, then the signal is given to the 555 timer. And then, of course, by sensing the signal received from the touch plate, the 555 timer activates the LED. And of course, the LED glow is indicating that the touch made to the touch sensor or plate. So this one is useful in many things. So for example, maybe if your car bump into something, or if it touches your touch sensor because it uh, push your probably your body of your car, then it detected that there is a collision, probably, okay, collision thing or minimal collision thing that's happened. Okay, so yeah, that is one practical application of this one. Maybe through door, maybe if someone touch that uh, doorknob of yours, or if someone touched that I probably your, I don't know, maybe your mouse, your drawer. Okay, so there's a lot of applications when it comes to touch sensor. Okay, so as long as it was moved, or as long as it was touched by heat, then it will detect that it was already touched. Okay, or could be via our touchpad in our laptop. So that is one I guess one great example of a touch sensor. Okay. So yeah, those are the again, basic examples or common examples of the sensor. So we have many more out there that is not included in this module. So the following is a small list of project based on few of the above mentioned sensors. So we have light, smoke, alcohol, touch, color, humidity, and then field sensors. You can just check them out with the use of these links right here. Okay. So yeah, that's pretty much it for this module. So any question or clarification so far?
Naman po, sir.
So if there is no more question, then I guess we can now proceed to your 15th lab or lab number 15. So in this laboratory, okay, so using LT-SPICE 17, aside from the given examples or circuit project sensors given on the module 4, create a circuit sensor project using the available components you can find on the LT-SPICE. Okay, so you can search on the internet, you can, copy exactly as it is, as long as it's not existing, it's not on the module 4. Okay, so if there is a uh similar project, let's say Miss Abigail and then Mr. Janelle have the same project, as as it is, everything is the same, so it's okay. Okay, since this one is an individual project, so it is now it is now just your conscience if you're going to copy the work of each other. Okay, so my only advice is, try to search first, and then if you can find one on your own, so there's a big probability that, of course, you and your other classmates have, found the same project or circuit that is not existing on the module 4. So uh, that one can also happen. So you don't cheat at all. It's just that, of course, it's coincidence that you and your classmate have the same project. Okay. So my only requirement, the main requirement of this project is it must have at least 10 components in it. So you can have more, you can have 15, 20. So yeah, it's just that in here, of course, connecting wires are not counted. Okay. So one resistance, or let's say 5 resistors, 3 capacitors, one power supply, and so on and so forth. So that depends on your project. Okay, so do not count wires as a one component. Okay, so it is not counted. Okay, so in this project, okay, so of course I need the title of the project, the description of the project, and then the list of components that you will use and their numbers for each components, or the count of each component, and then the circuit diagram, of course, using the LT-SPICE 17. And then just give me a short uh, message regarding with the hindrances or problems that you have encountered while creating or doing the project. Okay, so you can just do this one on the Microsoft Word, well, of course, except for the circuit diagram. So you can just copy maybe or use the snipping tool and then paste your circuit diagram on the Microsoft Word and then send it here as a file upload. So are you guys able to follow or get the AutoSpice, I mean the 15th lab?
Yes, sir.
Okay.
Sir, may question po.
Yes.
Sir, dun sa yung sa circuit ba, hindi na po kailangan yung graph niya or yung circuit lang talagang ipipaste dun, sir?
Just the circuit. I don't need the, what is the input, what is the output, what is the measurement. So
Okay,
no,
sir.
no need for those items. Okay, as long
Okay, sir.
as it's a legit circuit, yun yung main requirement ko lang dito is it was experience, in creating a sensors with the use of sensor, because we've been using LT-SPICE, but it's just with the use of common components like resistors, capacitance, how to measure them, and so on and so forth. So yeah, what I want you guys to experience is how to create a project or how to create a circuit with the use of a certain sensor. Okay, is that one? And of course, for the last activity for this week 9 and 10 is the case study. So in module 4, you have learned the different types of sensors and their importance. So I just have one simple question. So in your place or house right now, okay, or in boarding house, apartment, so or even condo, hacienda. So what is the most useful sensor that you need to have right now and why? Okay, this is that. This one sensor. Okay. Justify your answer on why that sensor is the most useful or maybe beneficial or important that you need to have right now, as in right now. Okay, so not in the future, but right now. Okay. All right. So are we clear for your 15th lab and then for your case study number 4? Hello, hello. Are we clear? Anyone has a question?
None, sir.
Okay. So yeah, just those. And then their due dates will be on March 25. So you guys have 3 weeks from now. 7, 14, yeah, almost 3 weeks. So I don't what happened to my dates, to my calendar. So I guess I need to restart my laptop. Anyway, so today is March 4. So we have exactly 21 days from now. So yeah, this is that for now. And then we'll finish everything probably next week or next week for the last module, which is module 5, basic measurement theory. And then after that, we're done with this course. And then the remaining time will be given as your free time or extension for the laboratories. Okay, and then probably our last meeting will be, discussing the coverage of your final exam and then probably answering some of your concerns if ever there is. Okay, before your final exam. Okay, so anyway, yeah, this is that for now for today, and just wait for my announcement if we will meet next meeting. Okay. So yeah, you guys may go now and yeah, keep safe. And as always, thank you guys for coming. I really, really appreciate it. So
Thank you,
goodbye and
sir.
Thank you, sir.
Thank you, sir.
bye.
Bye-bye po.
Thank you, sir.
Goodbye. Thank you.